All right, so section 2.1 talks about set concepts. Okay, let's see. It says a set is a collection of objects which we call elements or members of the set. And there's three ways that we're going to use to indicate a set. The first way is called the description of the set. The second is going to be in what we call roster form, and the last one is going to be something we call set builder notation. Okay, so the first one here says, let's talk a little bit about descriptions of sets. And the example here says, write a description of the set containing the elements January, February, March, April, May, June, July, August, September, October, November. Okay, so what is the description? These are going to be the months of the year, right? Okay. Now, let's take a look at the next ones. So look at the next set. It's just the list of numbers, 1, 2, 3, 4, 5, 6, 7. So before I get to that, guys, I want to point something out. I'm just going to kind of scroll down right here in my notes. Okay, if you look right here, these are what we call the natural numbers. So the natural numbers are the numbers 1, 2, 3, 4, 5. The little dots mean we go on forever, right? Okay, so when I look at these, this one actually stops at 7, right? So we could say this is the set of natural numbers we could say less than or equal to less than or equal to 7, because 7 is the biggest one that's in that set. Okay. All right. So look at the next one, V. The set V has the letters A, E, I, O, U. Well, this is the set of vowels, right? Remember that from elementary school, consonants and vowels? All right, and the next one here, oak, maple, elm, pine, okay? Set of different trees, right? Okay, good. All right, so now let's keep going. All right, so definition, again, we have the natural numbers, okay? And we're going to express each set in roster form. So guys, roster form, let's see if I can write it right here. I'll write it in red. This is basically just a list, okay? So like the way this set was given to us, that's roster form, that's a list. The way these were written out here, these were already in what we call roster form because it's just a list, okay? So now let's take a look. Oh, let me pause this real quick. All right, sorry about that, guys. My cat came out making a little noise. All right, so let's take a look here. The set of the natural numbers that are less than 6. Okay, so it's going to be my set A. Now, if they're going to be less than 6, so we know they're going to start like this. 1, 2, 3, 4. Now, less than 6, I would have to stop here because 5 is the biggest number that's smaller than 6. I couldn't put 6 itself because it has to be smaller than 6. Okay. Let's take a look at the set B. The set B says the set of natural numbers less than or equal to 45. Okay? So 1, 2, 3. Now guys, I'm not going to expect you to write out the entire set, right? And even when you're doing your homework, you're not going to have to. So we're going to put little dots. Now I want to say in your homework, they're going to have little boxes. And they might even have up to 3 little boxes. And in those boxes, we're going to have to place, for instance, the last 3 numbers. Now look what it says, less than or equal to 45. So in my last box, I would write the number 45. The one before would be 44, and the one before that would be 43. Okay? All right. Now let's do part P, or part C, which is the letter P. Oh, let's see, the set of the planets in Earth's solar system. Whoa, man, this is probably like 4th grade. Let me see if I remember this. So let's see, we have Mercury, Venus, Earth, Mars, let's see, Neptune. I don't even know if I'm in going in the right order anymore, but let's see. Jupiter, Saturn, Uranus, no bad jokes, and let's see, Pluto. And I think that's all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. We got 9 of them, right? Okay, so there's our set P. Okay. Let's see. Express the following in roster form. Okay, the set of the natural numbers between 7 and 12, and then look at part B. It says the set of the natural numbers between 7 and 12 inclusive. Okay, so inclusive means we're going to be including those two numbers. So if I were to do, say, part B first, okay, I'm going to do part B first. I would go 7, 8, 9, 10, 11, and 12. So there we go. And then my set A, if it's not inclusive, I'm not including the 7 or the 12, so then we would just start with 8, 9, 10, and 11. Good. So let me kind of keep moving along here. Okay. Oops. All right. So the next part here, guys, it says the symbol, and there's this little funny looking E. The way we read that is, this is the way it's read, is an element of. Okay. Is used to indicate membership in any set. It says, in example 3, because 8 is an element of the set A, we write 8 is an element of A. So what they're referring to is this one right here. 8 is an element of this set. Okay. We could also say 6, and the way we read this is not an element of. Okay, so we notice right here is not an element of the set A. Okay. So let's take a look here. We have something called set builder notation. Set builder notation, guys, it's a little, it looks a little intimidating. Hopefully it isn't, but they're always going to be written sort of in this form here. Okay, we're going to have our set. Usually our sets, we always use a capital letter, equals, and then we're going to have our braces. We're usually going to use the letter X. Then this little vertical line will come in here. So it's going to say D is the set of all these elements X. And then this little vertical line just means such that, and then we're going to save what it is. Okay. So let's go through this first example here and see if we can figure this thing out. So it says write the set B in set builder notation. Okay, so let's do this. We're going to go like this, the set B. I'm going to use the same sort of format right here, guys. Equals all the elements X such that. Okay, now let's take a look at this piece right here. Okay, so number one, those are all natural numbers, right? Because I don't have any like 2.8s or anything like that. No negatives. I don't even have the number 0. They're all 1, 2, 3, 4, 5. Okay, so they're natural numbers. So we're going to say X is a natural number. I'm going to abbreviate here, okay? Now, look at the last number here. So we could say less than, we have two options, guys. We can say less than 6, or we can say less than or equal to 5. Oops. Oh, come on, there we go. Or equal to 5. Okay, so it's a natural number less than or equal to 5. If we wanted to, we could have said it's a natural number less than 6, right? And now it says write in words how you would say it. Well, here it is in words. X is all the elements X such that X is a natural number less than or equal to 5. Guys, one thing I want to point out when you're doing your homework, a lot of these questions are going to be multiple choice. So you're not going to actually have to write everything out, but you are going to have to know which is the proper one, okay? All right. So let's take a look at the next couple of problems here. It is asking us to write it in set builder notation. So we're going to do the same thing here. The set B, because that's the letter we have here, is equal to the set of all elements X such that X is a natural number and we could say, we use this sort of idea in one of the problems earlier here in 2.1. We could say between 7 and 14, but we have to include the word inclusive, right? inclusive because we are including those numbers. Now, if we didn't want to use the word inclusive, then we would have gone one number smaller and one number bigger. So we could have said between 6 and 14, but we wouldn't have used the word inclusive. Does that make sense? Not 14, I'm sorry, but 15. Oops. There we go. 6 and 15, because we need to go one bigger because we're actually looking at the numbers on the inside, right? Okay, let's take a look at part C. Okay, I'm going to do the same thing, x, such that, okay, x, these are still natural numbers. Now, I know we're not using all of them. But look at these numbers, 3, 6, 9, 12. The next one would be 15, 18, 21, so on and so forth. Natural number, and these are all multiples of 3. That doesn't look like a very pretty 3, does it? Let's fix that a little bit. There we go, a little bit better. Okay, V is the set of x such that x is a vowel, right? These are all vowels. Okay. All right, so I hope set builder notation makes a little bit more sense now that we've gone through a few of them. Let's take a look here. So it says a set is well defined if its contents can be clearly determined. The set of U.S. presidents is a well-defined set because its contents, the presidents, can be named, right? We can put them in order. George Washington. No, I don't know number 2. I know someone they were going to say Abraham Lincoln, Grover Cleveland, right? George W. Bush, George Bush Sr., Bill, right? I already said Bill Clinton. No, President Obama, Donald Trump, right? You can throw all those names in there. Okay, so that's what we call a well-defined set. Now look at the next part here. It says the set of the best 3 movies is not well-defined because of the word best, right? Best to me could be very different from best to you, right? So that's more of an opinion. So when things are opinions, they're not well-defined. When you can actually make a list of everything in that set, then that's what we call well-defined. Okay, so let's take a look here. Determine if the set is well-defined or not well-defined. The set of the best musicians. Again, best is an opinion, so this here is not well-defined. The set of the Academy winners in 2014. This is well-defined, right? We could always go to Google. We could do a search and say, who were the Academy Award winners in 2014? And we'd find that set. We could go to the Academy Awards webpage. We could find the list of those people, and there's evidence that these are the people who have received the Academy Awards. Okay, so the next one says a set is said to be finite if it has no elements or if the number in the elements in the set is a natural number. So the set B containing the elements 2, 4, 6, 8, 10 is a finite set because the number of elements in there, how many numbers do I have? 1, 2, 3, 4. We have 5 elements and 5 is a natural number. So it's finite if there's no elements or the number of elements is what we call countable or it's a natural number, okay? Let's see, a set that's not finite is said to be infinite. The set of counting numbers is one example of an infinite set. So infinite means it keeps going on and on and on forever. Even though we can count them, it never ends, right? Okay, so let's see. Is this an infinite or a finite set? Well, notice what the little dots mean. It means it keeps going on. This is going to be an infinite set. Okay. The set of multiples of 3 between 0 and 40. Well, we could find that, right? We could say, look, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39. I have to stop here because they have to be numbers between 0 and 40. And then I could, if I wanted to, I could count them. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is going to be a finite set. There are 13 elements in that set there, right? Okay. The set of fractions between 1 and 2. So let's think about a fraction between 1 and 2. What about 1 and 1/2? Could we also do 1 and 1/3? 1 and 1/4? 1 and 1/5? Do you see that I could keep playing this game and I wouldn't even get all the fractions, but that's just one sort of type of fraction that would be between 1 and 2, and that would never end. So this here again, guys, would be infinite, right? And the set of apple trees in Grow More Farms Orchards. Okay, so here in the valley we don't have apple trees, but we do have citrus groves, right? So we could drive down, say, to Mission, drive down 107, go over there by La Homa Road. There's going to be an orchard there, and you know, it might take all of us. The whole class might have to go, but we could go down row at a time, and we could count the trees in our row, and then we could meet at the end of the orange grove, and then we could each say, well, I counted 28 trees, or I counted 31 trees, or whatever, and then we could take all those numbers and we could add them all up. And it might take us a long time to do it, but it could be done. So we would say, oops, that this is a finite set. It might be a big set, but it would be finite. Okay. All right. Now, for the next part here, it says, is the statement true or false? Okay. So look what we're asking for. Is B an element of this set? All that's telling you is the letter B one of the letters in here? Well, we would say yes, it is. Okay. Is H one of the letters in here? No, it's false, right? And we would say H is not an element of the set A, B, C, D, E, and F. Okay. Now, guys, I'm going to come back to this third one in a minute. I want to ask us this one here. Look what this is saying. 3 is not an element of the set where X is a natural number. This is how I read this part. It's a natural number, and it's odd. Okay, so let's think about natural numbers for a minute. Remember, 1, 2, 3, 4, so on and so forth. Okay, so number 1, it is a natural number. Okay. Number 2, is the number 3 odd? Yeah, it's odd. Numbers like 1, 3, 5, 7, those are odd numbers, right? This is saying it's not a natural number and it's not odd. Well, that's actually false because it is a natural number and it is odd, right? Okay, so coming back to this third one here, the reason I wanted to kind of come back to this one, look at the difference between, say, this problem we did here and this problem we did here. If you notice, this one here doesn't have the little squigglies like this one does. This is actually going to be false, and I want to explain why. In order for it to be true, it would just have to be like this. E is an element of, right? Or the other way that it could be true is if we left these little squigglies here, then all of the letters in here would also have to have the little squigglies. So we'd have to go A, B, C, oops, come on, there we go, D, and E. It would have to look like that, okay? So that's why it's false, okay? It would have to have either no squigglies, or all these guys here would have to have the squigglies like we got over there, okay? All right, let's see, what else do we have here? Empty set, okay? The empty set is the set that has no elements, okay? And the way we symbolize it is we put the little squigglies with nothing inside it, or we have a 0 with a slash through it, like that, okay? All right, the cardinal number. The cardinal number of a set A, the way we write it is n with parentheses A, is the number of elements in the set, okay? And equivalent set. So it says the set A is equivalent to set B if and only if they both have the same number of elements. The elements don't have to be the same, but they have to have the same number of elements. Then we can call them equivalent sets. Okay, so remember, this here, the way I understand this, this is just telling me how many elements are in the set A. So here's my set A. I have the numbers 2, 4, 6, 8. 1, 2, 3. There's 4 elements there, right? What about the set in B? There's 1, 2, 3, 4, 5, 6. There's 6 elements in B. Look at C. Do you see how there's nothing inside there? Well, the number of elements is 0. Okay. D, let me count how many elements. I got 1, 2, 3, 4, 5. Okay. All right, so none of those sets are equivalent because they all have a different number of elements in them, right? Okay, so now let's take a look here. It says a set, equal sets. A set A is equal to set B, symbolized by A equals B, if and only if set A and set B contain exactly the same elements. Okay. So now look what it says. Determine if they're equal, equivalent, both, or neither. All right, so let's see. First off, let's see if they're equal. Lion is here. The lion is also here. Tiger is here. Tiger is also here. Monkey's here. Monkey's also here. Okay, so far we know that they are equal. Now the second part says, are they equivalent? Remember what equivalent means. Let's find how many are in A. 1, 2, 3. How many are in B? The same 1, 2, 3. So they're also equivalent. Well, if they're equal and equivalent, then they would have to be both. Okay. All right. Let's take a look at the next one. We have grapes, apples, and oranges in the set A. We have grapes, peaches, apples, and oranges in the set B. So I know that they're not equal. Okay. Well, let's see if they're equivalent. How many are in A? 1, 2, 3. I have 3 fruits in A. I have 1, 2, 3, 4 fruits in B. So they're not equivalent. So this one here is going to be a neither. Okay, that's going to be a neither. Okay. And that right there, guys, is section 2.1.